Hi everybody, it's Mr. Han, and this week we're looking at reflection. And today we're going to look at specifically the law of reflection. So by the end of this lesson, what I want you to be able to do is be able to explain and use the law of reflection in projecting images from a mirror. So first thing we need to do is make a distinction between regular reflection, sometimes called plane reflection, sometimes called specular reflection, and what's called diffuse reflection. So I'm going to start with regular reflection first. This is what you see when you look into a mirror, or if you look out over like a still lake, okay, or still water on a pond, okay, or if you were to look at a piece of glass on an angle and see a reflection in it. This is called regular or plane or specular reflection. And what's happening if we kind of zoom in on the surface of the material, so let's say this was my water and it's very still right now. Okay, what you'll notice is that the surface of that material is very uniform, and so incoming light that hits that surface, okay, will bounce off very consistently. So it's going to follow the law of reflection. The angle that it comes in at is the angle that it leaves at. But if you look at subsequent rays of light, they will also bounce off at consistent angles. And so what this allows for is if you have, for instance, like a picture here of, let's say, an apple, okay, that light from that apple will reflect off that surface and then into your eye, and so you can see the reflection of the apple in that smooth water. Now, diffuse reflection is how we see other objects that we can't see our reflection in. This is diffuse reflection, and oftentimes with some materials you get sort of a mix of both. Okay, but let's take some examples of things where you really can't see a reflection in them. Sweater, for instance, a piece of wood, or some curtains. Those materials don't reflect a lot of light. Okay, we can see them because they're reflecting light, but they don't reflect images. There's no light shining off of them. If we were to zoom in on their surface at like kind of microscopic level, even though they may seem smooth, okay, they actually are very bumpy on the surface. And what happens is when light comes in off the surface, okay, it's still going to follow the law of reflection, except because of the differences in the surface, it's going to bounce off at different angles. Okay, so these surfaces are slightly different, okay, and so the light will bounce off at different angles. It can't form an image for our eye to recognize, so that's why you don't see your reflection in a sweater. You can still see the sweater because some of that light is going to reach your eye, just not all of that light will reach your eye, and so you see a reflection, or you don't see a reflection, but you see the sweater itself. So here's sort of regular and diffuse reflection, sort of again, kind of an overview. Again, if we had a apple here, okay, we're looking at it over here, okay, what happens is all the light from that apple hits our mirror, okay, and reflects back. None of it's lost. It's all going to come to our eye, and so we can see an image of that apple in the mirror. Okay, same situation here. Here's my apple, okay, but this surface here is wood, okay. If I zoom in on it, very little of that light is actually being reflected from the apple and into our eye, and so we can't actually perceive a reflection there. A couple things we need to talk about with images in mirrors. Okay, the image is not an exact copy of the object itself. It's going to be altered somehow. So if we're looking at a plain mirror and you hold up your left hand, it'll look like it's your right hand staring back at you. If you were to hold up text, if you had text written on your t-shirt, okay, or in a textbook, okay, that text is going to appear reversed in the mirror when you hold that text up to the mirror itself. And this has some neat applications. So on ambulances, you'll notice that oftentimes they'll have the word ambulance written backwards on the front. And the reason for this is when you look in your rear view mirror, you can quickly read that in the right direction, that that's an ambulance. The other thing we need to talk about is this idea of light rays. So whether light rays are hitting a smooth surface or a rough surface, they're going to follow that law of reflection. So light rays are just a way that we kind of conceptualize how light is propagating. So last week we described light as a wave. Now, instead of drawing waves, which would make our pictures sort of difficult to follow, difficult to see, what we do is we actually turn that wave into a ray of light, so a single beam or line of light. Okay, and the law of reflection basically says that when incoming light hits a surface, it has to leave that surface at the same angle it came in. Okay, and we always measure this relative to what's called a normal. The normal is kind of this imaginary line that comes up between the middle, okay, and it looks something like this. So this incoming ray has to be equal to the outcoming ray when we measure the angle between the normal. And this law of reflection is going to apply to both flat mirrors, which we'll talk about right now, and curved mirrors, which you'll hear a little bit more about later on in the week. Okay. When you're looking at a plane mirror, the image appears to be far behind the mirror, and this leads to an interesting thing about images, which is what we call virtual images. So virtual images are images of things that can't really be there. It's our brain trying to make the most sense of the light that it's receiving and then creating an image. So when you look in a mirror, you see yourself standing behind the mirror. But you know, if you were to go to the side of the mirror, there's nothing behind the mirror. The mirror might be hanging on the wall, for instance. Okay, there's no light coming from behind the mirror. You're not actually standing behind the mirror. It's your brain trying to make sense of what's happening. We call that a virtual image. It's something we kind of take for granted because we look at mirrors all the time and we use them sort of day to day, but really what's happening is it's this fantastic sort of trick that's being played on your brain. So how does this happen? When we look at the light traveling from, for instance, our hair, okay, it's going to hit the mirror and bounce back and hit us in the eye, okay? Your brain perceives that light as having come from behind the mirror up here. It traces that ray back, okay? So your brain has learned to kind of follow rays of light in order to create images. We'll do the same thing. We'll choose another point here. We're going to choose the chin, and we're going to follow the light, okay? So light from your chin is going to hit the mirror and bounce into your eye, but your brain is going to perceive that light as having come from here, okay? And these are just two rays. If we were to sort of extrapolate this to like tens of thousands, millions of rays, you could see how an image starts to form. And you can actually see this in the activity for this week, where simulation actually takes you through how a plane mirror works, and it does sort of extrapolate. It does that extrapolation for you and creates all these different points and eventually creates an image in the mirror. So the law of reflection, like we said before, is that this incoming angle has to equal this outgoing angle. So when a light ray hits a mirror like this, it has to leave like this. Okay, again, we call that the incident ray. So I use a fancy little I for that. And this is the reflected rays, little r for that. Okay, this is my angle of incidence, and this is my angle of reflection. And this dotted line in the middle is what we call the normal. Okay. Most importantly is that angle of incidence has to equal that angle of reflection. So now I'm gonna show you how to draw this so that we can kind of see how a mirror sort of flips an image sideways horizontally. So what I'm gonna do is I'm gonna get my ruler out. So here it is. Okay, now I'm gonna draw some lines. So I'm gonna get my ruler and I'm actually gonna tilt it up. And I'm gonna pick two spots. So we always just pick two spots. Again, we could draw it for every spot on our object, but we're not going to do that this time. So in the middle here, I have my mirror. Okay, so this is my mirror right here. Okay, and this is my object over here. Okay, and what I'm going to do is I'm going to just draw a ray of light leaving that object. Okay, and then what I'm going to do, I'm going to match that angle. I'm going to put my ruler like this. Now I'm going to draw that angle leaving. Okay, that's my reflected ray. I'll move this out of the way for a second. That's my reflected ray, that's my incoming ray. Now I'm going to put this back on that line. And so if we were to stand behind this object, and look at it, this is how our brain would perceive the ray. It would actually trace it back. So I'm going to go along my ruler here and just trace it back, and I can trace it back forever like this. Okay, so that light isn't really behind the mirror, but that's how our brain would perceive it. We're going to do the same thing at the bottom. Okay, so I'm just going to pick an angle again from the bottom point. It looks good. Okay, draw my line in. Okay, and then I'm going to flip it over and do the exact opposite line. Okay. There it is there. Okay, and draw its reflected ray. So there's the reflected ray. And again, what I'm going to do is I'm going to trace behind And again, I can just trace back like that. Okay, so that's that part set up. This is what the rays would look like. So incoming ray, outgoing ray. Now, what I can do next is draw what's called a horizontal line. So the horizontal line is really simple part of this. What I do is I say if there was a light ray, I'm going to do it a different color green, it came in like this, it would bounce straight back. So a light ray coming straight in at the mirror would just bounce straight back. And so if I was to continue it behind, it would look like something like this. And I'll just keep continuing it like that, something like that. Okay, and I'm going to do the same thing here. I'm going to do my horizontal line right there. Same idea, draw a line in, it would bounce straight back, and so your brain would perceive it as having come from back here somewhere. Now I got two sort of meeting spots. Okay, so one meeting spot is right here, where the green and the red meet, and right here is where the green and the blue meet. Those spots correspond to the original spots on my arrow, so now I can draw my arrow in like this. That will be the mirror image of that arrow. So we can see by tracing these lines how a plane mirror creates a mirror image. Later on this week we're going to get into curved mirrors and how they change images, but for right now what I want you to do is just kind of fill this in on your sheet. If you have any questions about it, please feel free to email me.